Wow, scientists just discovered a deep space fossil. And no, it's not a dinosaur. It's called Ammonite, a strange icy object that's been quietly orbiting far beyond Pluto for over 4 billion years. Now, this frozen relic might flip everything we thought we knew about the solar system. And that's because it could be the strongest evidence yet that Planet 9, the mysterious world we've been chasing for years, doesn't exist at all. Now, before we get into it, meet Ammonite, the newest member of our solar system. It isn't a planet. It's not even a dwarf planet like Pluto. You know, something in space that's big enough to be round, but too small to push other objects out of the way. Ammonite's even smaller than that. It's believed that its diameter is roughly 40 times the height of Mount Everest. And before you say, "Wait, that's not small," remember, in planetary terms, that's basically nothing. Earth, for example, is 30 times larger than that. Anyway, they officially nicknamed it 2023 KQ-14. Inspiring, huh? But people just call it Ammonite. The nickname comes from ancient sea creatures with spiral shells, just like the ones you might find on the beach. But this little space object doesn't actually look like a spiral or anything. The name is inspired by the way it moves, and its orbit is unlike anything else out there. In fact, it suggests that the outer solar system is way more complex and varied than we used to think. There are two big reasons for that. First, Ammonite's been on this path pretty much since the solar system first formed. Yeah, that long. And because it's been around since the very beginning, it's considered a space fossil. Okay, no jokes about the narrator. The second reason is its orbit. It's oval and massive, like a huge circle that's been pulled wide. Picture a perfectly round Formula One track. Cars race around it in no time. Now, stretch that track into an oval format and make it 432 times longer. Suddenly, each lap feels endless, right? Well, that's kind of what's happening with Ammonite. Its orbit is so stretched out that it takes about 4,000 Earth years to make just one trip around the Sun. And that's why it's super far from us. Okay, quick recap. Here's what we know about Ammonite so far. 1. It's super distant. 2. It has this weird stretched-out orbit that looks oval. And it's exactly those two things that led scientists to classify it as a sednoid. These space objects are so rare that we only know about 3 of them, and now 2023 KQ-14 is the 4th. So, sednoids. They are super far away. So far, in fact, that Neptune's gravity hardly affects them. And honestly, they don't make much sense to us, because their paths are nothing like the rest of the solar system. Look, here's how Earth, Mars, and the other planets move around the Sun. Their paths aren't perfect circles, but their orbits are almost round. Alright, let's zoom out. More. Stop. Now this is how sednoids move. See how their paths look totally different from the rest of the solar system? They seem more random and are shaped like squashed circles. Sednoids are also super cool. And I mean literally cool, as in freezing cold, since they're so far from the Sun. But also cool as in mysterious and awesome, because they might be hiding clues about the existence of Planet 9. So you've probably heard about this theory, right? Many experts seriously believe there could be a hidden 9th planet out at the edge of our solar system. In theory, it's this dark gas or ice giant, somewhere between 5 and 10 times the mass of Earth. It's believed to orbit the Sun on a highly stretched-out path that's totally out of sync with the rest of the planets. But we've never actually seen it or proven it. Experts just think it's out there because it would explain a bunch of weird stuff happening way out on the edges of the solar system, like the wild tilted orbits of sednoids. In other words, those bizarre paths might be caused by the gravitational pull of this so-called unseen Planet 9. Now, here's the thing about Ammonite. Its orbit is different from its cosmic cousins. Let's take a look. These are the orbits of the other 3 sednoids we know about. See how they all sort of cluster in the same general region of space? Like they're all being pulled in roughly the same direction? This suggests that something unusual happened way back in the early days of the solar system. And that pattern is a big part of what made scientists suspect the existence of Planet 9 in the first place. I mean, there's gotta be something out there influencing their paths. But things get even weirder when we look at Ammonite's orbit, because its path doesn't line up at all with the other three sednoids. In fact, it's actually pointing in the opposite direction. And that might mean just one thing. We might have to say goodbye to Planet 9 for good. Or maybe we've just discovered that it's actually a ghost planet. You know, like the ghost of someone who once lived on Earth but isn't here anymore. Somehow, traces of them still linger, like in a haunted house where something keeps moving stuff around in the kitchen cabinet. Well, Planet 9 might be just like that, only in space. It might have existed a long time ago, but at some point, for reasons we don't fully understand, it vanished. Maybe it even got kicked out of the solar system. But its old gravitational pull could still be with us, hunting Ammonite, giving it a little push. But now, we can't see it anymore. Of course, there's still a chance that its strange orbit is caused by something entirely different. Some believe it might be the result of an interaction with a rogue planet, and by that I mean a planet-sized object that doesn't orbit a star. Or the influence might even come from stars that passed by a long time ago, back when the sun was still young. But, let's be honest, no other theory is as intriguing as the existence of a massive hidden planet. Big question. Could Planet 9 still exist after this discovery? Well, yeah. But it would have to be much farther out than scientists originally predicted, because even though people believe it might be the fifth largest planet in the solar system, there's still a massive area out there where it could be hiding. Before, scientists thought Planet 9 was about 400 times farther from the Sun than the Earth. It's also around 13 times farther out than Neptune. If we launched a spacecraft today to go find it, it would probably take somewhere between 45 and 75 years to get there. And now, with the Ammonite theory coming to light, that distance might be even greater. We just don't know how much farther it could be, because, like I said, Planet 9 is still just a theory. It's more of a cool space legend at this point. But Ammonite is completely different. It's real. And it goes far beyond simply adding one more distant object to our planetary neighborhood. It's helping astronomers piece together what the early solar system might have looked like. Studying the evolution of its orbit and its physical characteristics is the key to getting closer to the truth. Because the reality is, there's still so much we haven't explored. Spacecraft have only reached a tiny fraction of what's out there. Most of the outer regions remain completely unexplored. Thankfully, we have tools like the Subaru telescope, the same one that spotted Ammonite. According to experts, it's one of the few telescopes on Earth capable of finding objects this remote. So now, we just have to hope more discoveries like this keep coming. And if we've just found Ammonite, what else could be hiding out there in the dark, waiting for us to find it? Any guesses? Our solar system is full of mysterious objects that come from, well, everywhere. In October 2017, researchers in Hawaii spotted a mysterious thing that they dubbed a muamua. This means a visitor from a faraway land in Hawaiian, or "that's a really big cow." It followed an escape orbit. It literally escaped from its planet's gravitational pull, like throwing a ball into space, never to return. This meant that this weird thing arrived from somewhere outside of our solar system. There were tons of theories about what it was, from a simple asteroid to an extraterrestrial spacecraft. Scientists even thought it was a chunk of nitrogen ice from a Pluto-like planet. Its strange shape only added to the mystery. The big changes in the light curves showed that this thing could be either elongated like a tube or more flat like a pancake. This thing was unlike anything we've seen before. Oumuamua didn't behave exactly like a comet or an asteroid. Comets are icy and form bright tails when they pass near the sun, while asteroids are basically just rocks and don't form tails. Oumuamua has no tail and doesn't release gas, like me. But it's not your average rock either. Its surface is very shiny, almost like polished metal. When it passed by the sun, it sped up, like it had a rocket on it. And it wasn't the sun's gravity that gave Oumuamua the sudden boost. Scientists aren't sure what caused it. So, what in the world was that thing? After years of study, scientists now think that Oumuamua is probably a comet with frozen hydrogen on its surface. This hydrogen reacted with sunlight, speeding up the comet and changing its path. Oumuamua likely got all that hydrogen from being exposed to tons of cosmic rays for a long time. It got some nice red tint from them as well. Oumuamua was a visitor from a young, chaotic solar system where collisions and migrations happen all the time. Such systems often toss many small objects around. It might have been pushed out by a planet like Jupiter, whose gravity is so insanely strong that it can fling huge things into outer space. The same thing often happens with comets here. Oumuamua already left our solar system, although similar objects visit us sometimes, about once per year. To learn more about these mysterious guests, astronomers plan to send a probe to chase Oumuamua. We'll use Earth's and Jupiter's orbits to slingshot it fast enough to catch up with the comet. But some of the unexpected visitors stayed a bit longer. In October 2019, NASA's Hubble Space Telescope took a picture of a bluish comet trailing dust and gas. It was already in the solar system at the time, around 260 million miles away from Earth, somewhere between Mars and Jupiter. We saw the glowing dust surrounding it, but we couldn't yet see its nucleus since it's way too small. Well, small is relative here. The thing is about 3,200 feet across, which is like the length of 9 football fields. In March 2020, Hubble images showed that a small fragment of the comet broke away from the nucleus. That means that the comet is very active, unlike Oumuamua. As we observed it further, we found that the nucleus is a loose mix of ice and dust particles. Its surface is also very similar to others, with rough areas and smooth blankets of icy, dusty debris. The comet was discovered by an amateur astronomer, Gennady Borisov, so it got the name Comet 2I Borisov. Congratulations! Scientists quickly confirmed it came to us from outside our solar system. And this thing sure was an enthusiastic tourist. It traveled at a breakneck speed of about 110,000 miles per hour. That's fast enough to circle the Earth 4 times in just 1 hour. This visit was fascinating for several reasons. Most comets in our solar system come from the Kuiper Belt or the Oort cloud. The Kuiper Belt is a region of space beyond the orbit of Neptune. It's like a big, distant ring around the Sun, filled with many small, icy objects. All of them are ancient leftover pieces from the time when our solar system was still very young. The Oort cloud is much farther. It's like a giant bubble around the solar system, also filled with super old icy objects. Most long-period comets come from there. But where did the comet 2I Borisov come from? We still don't know for sure. Scientists say that it likely formed in another star system, which could be either younger or older than our solar system. Would be weird if there was a third option, NASA. Anyway, it might have been kicked out from its home system, just like Oumuamua. Although Comet 2I Borisov is too small to hold on to its own atmosphere, it developed a coma when it approached the Sun. Now, coma is a funny name for that beautiful glowing cloud of gas and dust that surrounds the comet's nucleus. It forms when the Sun's heat causes the comet's ice to vaporize, releasing dust and gas into space. This one was friendlier than Oumuamua and gave us some more time to study it. As a result, we learned more about its cool, unique traits. For example, it had never interacted with another star. But, unfortunately, Borisov had to leave too. Now it's on a path that will take it back into interstellar space. However, there are many more visitors to come, and you might have heard of this one. The Great Comet of 1996. That's what we call the comet Hyakutake. It was also named after the astronomer who discovered it, Yuji Hyakutake. In a beautiful coincidence, it was discovered on New Year's Eve. On March 25, 1996, this thing passed by incredibly close to Earth, only about 0.1 astronomical units away, a bit farther than the Moon. It passed over the North Pole. This made it one of the closest comet encounters in 200 years. It was visible worldwide, and it looked very bright and beautiful in the sky, stretching out widely. And it didn't stay for one night only. It got more and more visible during March, becoming one of the brightest objects in the night sky by the end of the month. The comet only fully faded by the end of May. It's a long-period comet, which means it takes hundreds of years to orbit the Sun. The last time it visited was about 17,000 years ago, and now its orbital period increased to 70,000 years. But don't be upset, there are other comets that will brighten our days and nights. Besides, some space objects prefer to stay around for longer. Now, there's this asteroid with a multisyllabic name that, to pronounce, is above my pay grade. This name in Hawaiian means the mischievous one of Jupiter. Luckily, scientists had mercy on us and dubbed it BZ. Hey, speaking for all the other narrators, thank you. It's a small asteroid, only about 1.8 miles in diameter. You can guess from the name that it shares an orbit with Jupiter. But there's a cool catch. The asteroid moves in the opposite direction, which is known as a retrograde orbit. The unusual asteroid was discovered on November 2014. It orbits the Sun for about 11 years and 8 months, sometimes passing inside and outside of Jupiter's orbit. It's been this way for at least 1 million years, and it will remain so for about 1 million more. But why does it move so unusually? BZ might actually be an interstellar immigrant. Perhaps it passed by our solar system about 4.5 billion years ago, around the time when the Sun was just forming. Then it got captured by gravity, but saved its opposite orbit. Or maybe it came from the Oort cloud. Then it could get its weird orbit from the mysterious planet 9, a hypothetical planet that's believed to exist in our solar system far beyond Jupiter. In any case, this asteroid gives us more insight into the history of the solar system and how organic materials can travel to us from outer space. Now, at any given time, there are thousands of objects in our solar system that come from outer space. They stay here for different lengths of time, but sometimes we get lucky, and they end up teaching us a lot about interstellar space. You're standing next to a huge floor-to-ceiling window of the spaceship/wandering city you've been calling your home for a dozen years, along with a few hundred other people. You're watching a fascinating object nearing your spaceship, wondering if it'll bring an end to this journey and your life. It looks like an asteroid, but acts like a comet, moving as if something is pushing it. Can it be the engine created by another space civilization? Are you doomed, or are you about to have contact with a different kind of intelligence? Now, let's leave this post-apocalyptic fantasy and take a closer look at these space invaders called dark comets. The most intriguing question is obviously, what makes them move? Most likely it's some gas or material escaping from the surface of these space objects. Interestingly, until recently, no one has even been sure they existed. The first dark comet was discovered just a few years ago, and since then, researchers have identified 14 of them, including 7 new ones found just recently. The story of dark comets began in 2016, when scientists noticed something strange about an asteroid called 2003 RM. Its orbit wasn't quite what they expected. It had shifted slightly, and no one could explain that shift by typical asteroid behavior, when they received tiny pushes caused by sunlight heating an asteroid unevenly. Instead, the movement suggested that 2003 RM might have been releasing material, something comets often do. But there was a catch. The thing didn't look like a comet. There was no tail, no visible gas cloud. It was just a tiny dot of light, like a regular asteroid. At first, scientists thought 2003 RM was just a one-off mystery. But in 2017, a telescope spotted another strange object, this one from outside our solar system. It was Oumuamua. It too looked like an asteroid, but had a path that changed as if gas were escaping from it. The similarities between Oumuamua and 2003 RM made researchers think there might be more of such odd objects out there. By 2023, 7 more had been discovered in our solar system. These discoveries were enough to give this new type of object the name of dark comets. Now, scientists have enough data to start noticing patterns and learning more about their characteristics. And so, they have identified 2 main groups of dark comets. The first group, called outer dark comets, is larger, with sizes ranging from hundreds of feet to even more. They follow long elliptical orbits, similar to traditional comets that come from regions near Jupiter. The second group, inner dark comets, is smaller, usually tens of feet across. These comets move in almost circular orbits and stay closer to the Sun, near planets like Earth, Venus, and Mars. The main question these days is, where do dark comets come from? Can they be the remnants of larger bodies that broke apart? These space bodies could help us understand the history of the solar system. What if they had delivered the ingredients for life to early Earth? Once we study dark comets better, we might figure out if they contain materials like ice or organic compounds. And indeed, some researchers are sure that dark comets may contain or once have contained ice and played a big role in bringing water to Earth. According to a couple of studies, some asteroids in the asteroid belt, a region between Mars and Jupiter filled with rocky debris, might have ice beneath their surfaces, and this ice from the asteroid belt could have traveled into near-Earth space. In other words, it could be a pathway for water to reach our planet. So far, no one is saying that dark comets definitely brought water to Earth, but they might be another mechanism for moving ice from one part of the solar system to another. The study also hints at a connection between dark comets and a group known as Jupiter family comets. These are comets whose orbits are strongly influenced by the gravity of Jupiter, often pulling them inward toward the Sun. This connection makes it even more difficult to understand where dark comets come from and how they behave. Now, let's take a closer look at the differences between asteroids and comets. Traditional asteroids are rocky bodies that orbit relatively close to the Sun, typically within the ice line. This region is so close to the Sun that any ice on an asteroid's surface would turn directly from a solid into a gas, leaving behind only rock. Comets, in turn, are icy bodies that form farther from the Sun. When they approach the inner solar system, their ice starts turning from a solid to a gas tube, creating a visible cloud called a coma or a tail while releasing dust and gas. Dark comets blur these definitions. They appear as rocky asteroid objects without a coma or tail, but they have behavior typical of comets, and that's small non-gravitational accelerations. These accelerations occur when ice turns into gas, giving the object a slight push. After analyzing 7 known dark comets, astronomers estimated that between 0.5% and 60% of all near-Earth objects might belong to this mysterious category. And since dark comets likely come from the asteroid belt, ice is likely to exist even in the regions of the belt previously thought to be too warm. Now, near-Earth objects like dark comets don't stay in the same orbit forever. The near-Earth environment is unstable, and objects typically remain there for about 10 million years. Since the solar system is over 4.5 billion years old, this means that new near-Earth objects must constantly replace those that are lost. Now, astronomers have used computer models to simulate the movement of objects under the influence of non-gravitational accelerations. They've traced the paths of these objects over a span of 100,000 years and discovered that many ended up in the same regions where we find dark comets today. Now, do you remember that space rock 2003 RM, which was the first to be called a dark comet? Well, it provided a particularly interesting clue. Its elliptical orbit brings it close to Earth, then out near Jupiter, before returning to Earth again. This trajectory matches what scientists would expect from a Jupiter family comet, an object that was likely knocked inward from its original orbit. Most of the other dark comets studied, however, seem to have come from the inner regions of the asteroid belt, closer to Mars. Dark comets are often small and spin rapidly. Astronomers often describe them as dirty ice cubes, all because these objects are a mix of rock and ice, and when they cross the ice line, their ice begins to turn into gas. This process not only causes those small non-gravitational accelerations, but also increases their spin rate. And the faster these objects spin, the easier they can break apart into smaller fragments. The pieces that break off also have ice, and as they spin faster and faster, they break into even smaller pieces. This process continues until you're left with very small, fast-spinning objects. This cycle of fragmentation helps explain why dark comets are often so tiny, but it could also mean there are more of them than we currently know about. The dark comet research provides new insights into the distribution of ice in the solar system and its potential pathways into the near-Earth environment. It also raises intriguing questions. For example, how much ice remains hidden in the asteroid belt? Or could dark comets have played a role in delivering water or organic materials to Earth? One of the most important points is that dark comets may represent a significant part of near-Earth objects. If it turns out to be true, it could mean that our understanding of the population of near-Earth objects and their potential risks for our planet is far from complete. The processes shaping dark comets, from sublimation to fragmentation, could be a major factor in the evolution of icy bodies throughout the solar system. Luckily, these days, scientists have an opportunity to combine advanced modeling with observations, which can eventually shed light on that very elusive class of objects that could have clues to the history of water and life on Earth.
That tiny dot in the sky is an asteroid called 2024 YR4, and it gave scientists a serious scare. Early projections showed a 2.3% chance that it could hit Earth. That might sound small, but for an object big enough to wipe out a city, it was enough to raise alarms. Now, there's good news and bad news. The good: it's no longer on a collision course with our planet. The bad: it might be heading for the moon instead. Astronomers first spotted it in the El Sos Observatory in Chile, back in December 2024. Judging by how bright it appeared, they estimated its size to be somewhere between 130 and 300 feet wide. That's about the size of a football field. If something this big hit Earth, it could be truly catastrophic. I mean, not on the level of the asteroid that wiped out the dinosaurs, but still enough to destroy an entire city, depending on where it lands. Drop it over Paris, London, or New York, and you're looking at complete devastation across the city and nearby areas. That's why it was considered one of the most dangerous space rocks to ever come near us. It makes total sense that this asteroid became a bit of a celebrity. From the moment it was discovered up until February 2025, the risk of a collision just kept climbing. But now we can breathe a little easier. New calculations from NASA have completely ruled out any chance of impact. In fact, there's no serious threat from this asteroid for at least the next 100 years. Okay, but how did we go from this is a threat to, oops, we were wrong? That happens quite often, actually. I mean, an asteroid seems risky at first, then it gets even riskier, and then, out of nowhere, it's suddenly safe. Does that mean we can't trust their math? You see, the first time specialists spot an asteroid, it's really just a tiny dot of light in the sky. At that point, they have no idea what it is or where it's headed. Then they have to observe it again and do some math. That will help them figure out the path they're moving on. But even then, it's still a bit uncertain. They don't really know where the asteroid is going, so the risk corridor is this huge area where it could fly through. If any part of that corridor crosses Earth, the asteroid is considered a threat. Usually, at least 3 observations are needed to figure out its orbit. Basically, how fast it's moving and where it's headed. A lot of times, as they start to get a clearer picture, the risk zone still overlaps with Earth, so it looks more dangerous at first. But typically, as they keep tracking it, the risk zone gets smaller and moves away from Earth, and suddenly, the risk drops. And they keep narrowing down the uncertainties until they can confidently say, "Relax, y'all, it's not heading for Earth." And that's exactly what happened to just our famous 2024 YR4. So, we can all relax a bit now, right? Yeah, we know that 2024 YR4 won't hit us, but it could end up crashing into the moon instead. At first, projections said there was a 1.7% chance of that happening in 2032. But recently, that number has gone up a little to 3.8%. If it does hit the moon, though, it won't be dangerous for us. I mean, there won't be any shockwaves felt here on Earth, and the moon isn't gonna crack in half. Experts say nothing really shocking or concerning would happen, but it would be an awesome opportunity to see a lunar impact. If we're lucky, we might even catch the exact moment it happens. And if we miss it, we will still get to observe a brand new crater on our natural satellite. Such events are pretty common for the Moon, since it doesn't have an atmosphere to protect it from incoming debris. In fact, there are hundreds of detectable impacts each year. See those bright spots lighting up? These are real images of asteroids hitting the Moon. But specialists aren't just sitting around and waiting. They've been keeping an eye on lunar impacts for years. For example, the European Space Agency has a project called Naliota, where they use a powerful telescope in Greece to track these impacts. They've recorded over 100 tiny explosions from space rocks hitting the Moon. They also have the Lumio mission, which is a small satellite that counts lunar impact flashes on the far side of the Moon, the side we can't see from Earth. These observations help scientists understand how often the Moon gets hit and how this might affect astronauts and lunar bases. Now, 2024 YR4 might be a special case. That's because most space objects that collide with the Moon are really small. We've never seen a collision with something larger than about 160 feet. If YR4 does hit, it could be an amazing sight. So yeah, scientists are kinda hoping it happens. But 2024 YR4 isn't the only asteroid on the radar. There are actually quite a few others that have been classified as potentially hazardous. In simple terms, that means this one might cause us some trouble. You see, there are millions of big space rocks out there in the solar system, mostly chilling in the asteroid belt between Mars and Jupiter. But only a few ever get close to Earth, and even fewer actually pose any real risk. NASA calls asteroids that orbit within 30 million miles of Earth near-Earth objects. And within that group, there's a smaller bunch of really big ones that orbit super close to us. If one of those were to hit us, it could be a big deal. There are about 2,500 of those asteroids at least that we know of. But here's the good news. Specialists don't expect any of them to hit Earth anytime soon. A few might come pretty close though, or already have, like the 2014 TN17, an asteroid that's about 540 feet wide. It got pretty close to us in March 2025, zipping by just 3.2 million miles from Earth. That's roughly 13 times further than the Moon. So yeah, not exactly close, right? But when you think about the vastness of the universe, it's actually kind of near. In fact, that was the closest this asteroid has come to Earth in nearly 300 years. Thankfully, nothing happened, and that asteroid has already drifted away from Earth again. But it's not like you need to lose sleep over asteroids that could hit our planet. Little asteroids enter Earth's atmosphere every single day. It's the big ones we worry about, like the ones you see in Hollywood movies, like Armageddon. But asteroids like that are being constantly monitored. All the objects we know of today have 0 or 1 chance of impacting Earth. And if things change, there are a few strategies that could be used to save humanity from an impact. Take the DART mission, for example, which happened in 2022. This was NASA's first test of planetary defense. They successfully managed to deflect an asteroid off its course using a spacecraft. In this case, the asteroid didn't pose any threat to Earth, but it was the perfect test subject. There are also more experimental ideas out there. For example, lasers could vaporize part of an asteroid to create a thrust effect, pushing it off course. Another idea is the gravity tractor, a big spacecraft that slowly tugs the asteroid away using its own gravitational pull. But all of these are still just ideas for now. If we can't pull any of those off, authorities would probably still have enough time to evacuate the impact zones. So yeah, I wouldn't stress too much about an asteroid impact.
You know, many different things have nothing in common at first glance. The appearance of mysterious clouds over Stonehenge and the migration of wolves in Canada, patterns on the wings of a Caribbean butterfly, and strange footprints on the Moon's surface. These are all random facts, but people can see connections in these events. Let's see how it can happen and where it can lead to. Imagine reading some crazy article on one of the unreliable sites, forgetting about it, and then beginning to notice small details in the world that might indicate that the information in this article is true. You realize you've learned something unusual, but for some reason, other people don't see it or don't want to see it. You try to tell them, but no one wants to listen to you. And some people even think you've gone mad. Let's stop for a moment and see what kind of article you've read. So, in 2017, one not-so-truthful site published a story about a ship from another planet called Black Knight that had been spying on people for 12,000 years. But not long ago, agents from a secret organization managed to destroy it. Sounds like absolute nonsense or a plot for a cheap sci-fi movie. Of course, you don't believe it. But a few years later, you find a story about Nikola Tesla. Let's fast forward to 1899. The famous scientist was sitting in his laboratory in Colorado Springs conducting radio experiments. Suddenly, his receiver caught a strange radio signal. Then, after a while, another one. The signals came in with the same time interval, as if someone wanted to send a message. Nikola Tesla realized it could be something from extraterrestrial civilizations that were trying to start a dialogue with people using the most universal language, math. He also reported about this event in a magazine at the beginning of the 20th century and added that he hadn't deciphered the message. Okay, now let's forget about it and see what happened next. In 1927, an engineer from Oslo, who was fond of radio devices, was sending signals into open space. He was surprised when, sometime later, the same signals began to return to his receiver. It was as if the signals bounced off something big and echoed back, or something received these messages and then sent them back to the sender to make an acquaintance. The man quickly reported his discovery to scientific journals, and perhaps someone connected this event with Nikola Tesla's words about strange signals from space. All this were just prerequisites for the Black Knight. But the most exciting events started decades later. In the 60s, Time magazine published an article that said that the U.S. had discovered a satellite orbiting Earth and using unknown technology. A couple of years later, Project Mercury astronaut Gordon Cooper reported that he had seen a strange object during his spaceflight. But the Black Knight became really famous only in the late 90s when NASA published a series of images of a mysterious object. During the first flight to the ISS, astronauts noted weirdly shaped somethings and took several pictures. Then someone gathered all the facts, collected all the information about the black satellite, and discovered that it had been flying around our planet for more than 10,000 years. How did they figure it out? People managed to calculate the age of those radio signals that Tesla and the engineer had received. If this is true, the Black Knight appeared much earlier than the Sumerians in ancient Egypt. What if this satellite helped build pyramids and majestic temples? What if it had been watching over our development all this time and transmitting this information to another planet? What if mysterious images ancient people drew depicted the satellite? People began to suspect NASA and other space agencies of hiding information about the black object to prevent panic. And now, after having received all the data about the mysterious satellite, you might begin to suspect that the bizarre article may actually be true. This news is so improbable and ridiculous that no one will believe it. If you want to hide something, hide it in plain sight. And so, together with other enthusiasts, you start hunting for any information about the mysterious ship. You create forums, post photos of unknown objects, and become obsessed with this topic. You really believe in the reality of the Black Knight. Moreover, you don't want to question its existence, and people reading your articles do the same. Congratulations! You have become an ideal candidate for creating fake news in the yellow press. Such myths and urban legends seem attractive. The human brain feels pleasure when it finds fake secret information. The feeling of mystery, adrenaline, and shock can cause psychological addiction. That's why the stories about the Black Knight are still alive. Mysterious facts seem logical, and people stop seeing information that refutes their theories. The case of the Black Knight is no exception. The fans of this black object believe that Nikola Tesla received signals from some space civilization. But for some reason, they don't attach importance to scientific articles, which say that such radio signals could be sent by giant space objects like pulsars. A pulsar is a rotating neutron star emitting powerful electromagnetic radiation. Such radiation is often found in space. These radio waves don't imply the presence of a mind and a sender. The cosmos is full of such signals. The technology for detecting such objects were created in the 60s. Or maybe Tesla's device caught a signal coming from our planet. Besides, the scientists didn't say anything about the Black Knight. So why did people connect these two events? That story with the Norwegian engineer is still unexplained. Yes, his signals returned as an echo, but this had nothing to do with the flying object in question either. You might as well say that the satellite somehow influenced the Titanic. There's no logic in such assumptions. Strangely, no one connected the Black Knight with the Yeti or the Kraken. Now, let's return to that Times article about a strange object flying around Earth. It also stated it was a fragment of an American reconnaissance satellite. But fans of myths and legends apparently didn't notice this explanation. As for astronaut Cooper, who is said to spot some object during his mission, he actually saw nothing. He even showed a transcript with no reports about the black satellite. However, some believers in other civilizations keep silent about this fact. So, the main proof of the Black Knight's existence is the photos taken during the first flight to the ISS. The astronauts noticed this strange object and took pictures, but it wasn't a surprise for them because some part of the ship broke away during some work they did outside. It was a piece of thermal coating. The astronauts sent the photo to NASA, and the space agency assigned it a personal number, as it does with all such objects. A few days later, the Black Knight fell out of orbit and burned up in Earth's atmosphere. Almost all this information was recorded in official protocols. One of NASA's engineers, who knew the photographer of the black satellite, explained that those famous photos depicted an ordinary piece of the ship. There was nothing fantastic about it. But the fans of extraterrestrial rockets must have missed all this information. All these myths have long been debunked, and all the false facts have been refuted. But the Black Knight continues to live in many people's minds and on the pages of the Yellow Press. It has become a link between many reports of strange flying objects. Over the years, hundreds of stories have appeared about secret laboratories with extraterrestrial technologies, about NASA hiding secrets, and about creatures from other planets. And many people connected these myths with the black satellite. It has stopped being a real physical object. Now it's a cultural phenomenon. Remember how the main symbol of extraterrestrial civilizations was a flying saucer? It's not trending anymore. Today, the symbol is a black, weirdly shaped stone. Don't be fooled.
Remember that asteroid that wiped dinosaurs off the face of the Earth? Brace yourself. We might witness a similar scenario in our lifetimes. And this time, the consequences might even be more catastrophic. There's just one tiny difference. This new asteroid is likely to smack into the moon. No, this is not a sci-fi scenario anymore. There's this asteroid called 2024 YR4 that scientists say has about a 4% chance of hitting the moon in 2032. So what do? Try to gently shove it off course or blow it up? A bunch of researchers, including people from NASA, dug into this and suggested several options. Their worry is real. If that rock hits the moon, it could kick up a massive cloud of debris, and this cloud could spike to as much as 1,000 times normal levels for a few days. That's not just messy, it could endanger astronauts and satellites in low Earth orbit. One obvious idea is to nudge the asteroid so it misses the moon. Another is a full-on breakup. Basically, a deliberate explosion. Experts use a clever term to describe it, a robust disruption. But nuking an asteroid is totally untested. Nobody has ever done it before, and it carries huge risks. You could create a bunch of smaller but more dangerous fragments, or do something unexpected that can make things worse. In any case, the idea is out there for scientists to chew on. Now here's the backstory. 2024 YR4 was first spotted on December 27, 2024, and reported to the Minor Planet Center. That's the official hub that tracks all new asteroids and comets. Pretty soon, it showed up on NASA's Century Impact Risk Table, which is like the agency's watch list for any asteroid that could potentially hit Earth. For a little while, things looked sketchy. Out of 37,000 plus known large asteroids, YR4 was the only one with a real chance of smacking into Earth anytime soon. Its odds even climbed to a record 3.1%.
That might not sound like much to such amateurs as me and you, but in space terms, that's huge. Scientists were really paying attention. Luckily, after a few more months of better tracking and sharper observations, they nailed down the asteroid's orbit more precisely. Turns out its path isn't taking it anywhere near us after all. Its chance of hitting Earth has dropped so low it's basically zero now. So, we can breathe out and relax. Earth is safe. But the Moon? Maybe not. And that's why researchers are now debating whether to blow the thing up before it ever gets close. The thing is, asteroid 2024 YR4 is pretty big. Based on what the James Webb Space Telescope saw, it's about 220 feet long, roughly the size of a 20-story building. Not exactly a pebble, I'd say. At first, NASA thought there was only around a 1.7% chance that YR4 would crash into the Moon. But then, the Webb telescope checked again in March, and that number jumped to 3.8% right away. By May, it climbed once again. It was already sitting at about 4.3%. In other words, the more they looked, the more likely it seemed that this space rock might actually hit our natural satellite. On the bright side, these new observations helped NASA figure out where exactly the asteroid would be on December 22, 2032, with about 20% better accuracy. Now, if the asteroid really did smash into the Moon, NASA says it wouldn't mess with its orbit or make it wobble or anything dramatic like that. But, and this is a very big but a hit from something that large would kick up a ton of debris, and that flying space junk could become a real problem for satellites orbiting Earth, or even for astronauts on the International Space Station. That sounds alarming enough. That's why the story might take a turn straight out of a sci-fi movie. Scientists are seriously considering blowing the asteroid up. But unlike in a movie, this isn't about saving Earth this time. The most extreme idea is to launch a bunch of nuclear explosives at the asteroid before it reaches the Moon. The thinking is, if they can blow it to pieces while it's still far away, the debris will scatter safely into space instead of causing problems near Earth. But of course, there's the catch. While scientists know roughly how big YR4 is, they don't know exactly how much it weighs. And that's a huge problem. Without knowing its mass, space agencies can't design a precise mission to knock it off course. In theory, they could send out a reconnaissance spacecraft first, something to get close to the asteroid, measure it up, and figure out the best way to push it away. But researchers say there just isn't enough time. By the time we'd collect all the needed data and build the right hardware, it'd be too late to intercept the asteroid before the 2032 impact window. So instead of a gentle space nudge, some experts suggest going full Armageddon-style, that very robust disruption. Translated into human, it's blasting the asteroid apart with nuclear explosions. Sure enough, this idea comes with a massive risk. What if the explosion accidentally changes the asteroid's path and sends some fragments toward Earth? The researchers admit it's a possibility, but still think nuking it could be the most practical solution, given the circumstances. If the mission ever happens, it would need to launch sometime between 2029 and late 2031. This would give it just enough time to reach and intercept the asteroid before it gets too close to the Moon. Now, nuking space rocks might sound over the top, but NASA actually has some experience with asteroid defense. Back in 2022, they pulled off something groundbreaking with their Double Asteroid Redirection Test, or DART. That mission was all about proving that humans could physically change an asteroid's path without using explosives. NASA launched a small spacecraft in November 2021, and after almost a year of travel, it crashed head-on into a tiny asteroid named Dimorphos at about 14,000 miles per hour. The idea was simple. If you hit an asteroid hard enough, you can slightly change its orbit, just enough to make it miss Earth someday. And it actually worked. The test showed that even a relatively small spacecraft could make a serious difference. Now, the European Space Agency wants to double-check exactly how much of an effect that crash had. In October 2024, they launched a follow-up spacecraft called Hera from Florida's Cape Canaveral Space Force Station. Hera's on a 2-year journey to reach Dimorphos and its bigger partner asteroid, Didymos. By October 2026, Hera will enter orbit around the asteroid pair and start collecting data, basically checking NASA's math. ESA scientists hope that once they analyze the impact site, they'll find out how effective DART was at changing the asteroid's trajectory. If it turns out that kinetic impact, aka smashing a spacecraft into an asteroid, works well enough, future missions might use that technique again. Maybe even for YR4, if it ever becomes a real threat. But if it doesn't, that's when the nuclear backup plan might come off the shelf. Either way, scientists are making sure that if a space rock ever threatens Earth or the Moon, humanity will have more than just a Hollywood script to rely on. By the way, people at NASA run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it, where might it hit, what should we do? It's like a massive brainstorming session to make sure that if this ever happens, we won't be starting from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are the folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. No one knows exactly how big the asteroid is or where it can hit. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life.